So hello guys, welcome to another video of GK. In this video, we will learn about the three laws, Newton's three laws of motion. Okay, the first law of motion. What is the first law of motion? This law states that an object in rest position will move when an external force acts on it, and an object in uniform motion will also move in a different direction when an external force acts on it. So it would be looking difficult by reading the line, but uh, I will explain it through the example. Okay, this is normally taken as a definition of inertia. Okay, so inertia is this only. For example, footballers hit the ball from rest state. So when footballers and soccer players for Americans, so when the ball is in the when the game is going to start, the one footballer kicks the ball, right? And the ball was first in a rest state, and when he kicked it, it went into a moving state, right? And when they try to tackle the ball, tackle like when they try to get the ball from their opponent, they change the direction of the moving ball. When they try to tackle the ball from their opponent, they hit the ball, and when they hit the ball, the direction of the ball changes, and uh, thus following first law of motion. Okay, so as you can also see in this picture, uh, so you can see example in this picture, like if when you are in a car and you are driving the car, and when you hit a brick wall and the brick wall doesn't break, and the front of the car gets collapsed, right? And but as the car was moving, so the passenger you will still be moving forward at the speed of the car, because this is what is it this is inertia. Okay, so when the car hits a brick wall and you are in it, so the car stops. But this law or inertia, same thing. Okay, this law makes you still travel at the speed of the car even when the car is stopped. Okay, so okay, second law of motion. This law states that acceleration of an object depends on the net force applied on it and the mass of the object. So it can be represented in the famous formula: force is equal to mass times acceleration. Okay, so acceleration of an object depends. This law states that acceleration of an object depends on the net force. So net force means like only one force is being acted on the object and not two or three forces. Okay, applied to it, and the mass of the object. Okay, so these are two variables. These are two variables: net force applied and the mass of the object. So this means that the acceleration of the object is directly proportional to the net force and inversely proportional to the mass. So like as you can see here, force is equal to mass times acceleration, right? So acceleration of the object directly proportional to the net force, because the more the force, the more the acceleration, right? Because right, sorry, yes. So the acceleration of the more the force, the more the acceleration. That is directly proportional. Okay, the more the force, more the acceleration, and inversely proportional to the mass. This means that acceleration, the less the mass, the more the acceleration. When force is constant, the less the mass, the more the acceleration. If the mass is more, then the acceleration is low, and if the mass is low, then the acceleration is high. So inversely proportional means that when one decreases, then the other increases. Like when the mass decreases, then the acceleration increases when force is constant, and when mass increases, then acceleration decreases, right? Okay. For example, when you push a heavy box, you put a lot of force, right? When you push a heavy box, you have to put a lot of force. But when you push a light box, you have to put less force, right? So as you can also see in this picture, if you apply more force to an object, it accelerates at higher rate because uh, force is acceleration proportional to force, right? So if you have higher force, then and the mass is constant, then the acceleration will increase, and if you have less force, then the acceleration will decrease. And in this picture also you can see this is the same thing, like force of our hand accelerates the brick, okay, and twice as much force produces twice as much acceleration when the brick has the same mass. And okay, twice the force on twice the force on twice the mass gives the same acceleration, because twice as much force produces twice as much acceleration, and when the mass of the brick increases, and we still will still provide uh, twice the force, then it will be the same as the first one, right? Because 2 and 2 cancel and become 1. Then the third law of motion, it is the most famous law of motion. This law states that for every action there is an equal and opposite reaction. So this is mostly known by every person. This means that if object A is exerting some force on object B, then object B is exerting the same amount of force on object A. Like if there is an object A, like this is an object A, and this is an object A, okay, and this is object and this is object B, okay. So when object A puts some force on object B, then object B puts the same amount of force on object A. Okay, so for example, when we walk, we push on the ground, and the ground exerts the same amount of force on us, so we walk. So as you can, if we walk, like if I am this person, okay, and I am on the ground, and if I walk, I put some force on the ground, okay, and the ground exerts the same amount of force on me that I put on the ground, so I can walk. When you throw a ball, you put some force on the ball, and the ball exerts the same amount of force on your hand. So when you have a ball in your hand and you throw it, okay. So when you throw it, you put some amount of force on the ball, right? So the ball also puts some amount of force on you. So the ball goes away. As you can also see in this picture, when you fire a gun, when you fire a gun, the force of the bullet coming out of the gun makes the gun recoil, like the goes back, because the acceleration of the bullet puts up the same amount of force on the gun, so the gun goes back. So this is the floor one only, and boy's feet exerts force on board, so board exerts force on feet. Okay, so thank you for watching my video, and please like, share and subscribe. And tomorrow we will learn how to program a calculator in small. We will learn about the basics in small basic tomorrow. So thank you for watching my video, and I will upload videos every Saturday and Sunday from now on. Okay, so thank you for watching my video, and we will meet in the next video. Bye.